Hi there, you're in the lab with me, JJ. Today is Learning the Art of Electronics Day. Today we're learning the art of electronics. My silly job title for today is Bolt Boy. Today I'm the Bolt Boy. Of course, in the Learning the Art of Electronics videos, we work through the book with the same name. This is our book over here. Today we'll be continuing with section 1L.4.2 and we'll be building a voltmeter. So we'll do the prag first. We'll jump over to the bench and we'll do our circuit. It shouldn't take long. Once it's done, we'll pop back over to the computer and we'll review our notes. So yeah, let's jump over to the bench and let's make a voltmeter together. All right. Well, here we are on the bench, and I'll just grab our book. So we're up to section 1L.4.2, 10 volt voltmeter. So we're going to show how to use the movement plus whatever else is needed to form a 10 volt full-scale voltmeter. That just means that 10 volt applied to the input of your circuit should deflect the needle fully. Draw your circuit. Note, this is a good time to start getting used to our canny use of approximations as we design. As you specify the resistor that you want to add to the bare meter movement, recall that you are limited to 5% values. Resistors whose true value is known only to lie within plus or minus 5% of the nominal value. Does the movement's internal resistance cause a significant error? What does significant mean? Well, you might compare the contribution of the internal resistance against the contribution of error from your uncertainty about the value of the resistor that we hope you have included. Okay, cool. And then after that, we're going to build an ammeter. So today we're just going to build the voltmeter. We need to add a series resistance. And we need to figure out what value it should be. So it said to draw our circuit. We're going to have to figure out what our circuit will be. Let's have a look. What have we got here? All right, here's our notebook and pencil. And today is the 9th of the 12th, 2025. With the day first, because I'm Australian. This is Learning the Art of Electronics 1L.4.2. And we're gonna I'm gonna send in, well, we're gonna send in maximally 10 volts, but let's test with 5 volts. And it goes into our series resistor that we haven't decided yet what value to use. And this is our meter, and this is ground. So we want maximally deflect the meter at 100 milliamps, microamps. So let me think about it. All right, so first of all, I'm going to change this from 5 volts and I'm just going to go straight for 10 volts. So rather than deflecting it halfway, we're going to deflect it the full way. So we give it 10 volts. Maximum current through there is 100 microamps. Oh, by the way, these are the meters that we'll be using. I got a whole box full of them. You can see the ammeters on the left and voltmeters on the right. Last week we configured this one with the banana plugs on each side with these big honking washers on the back. So that's the meter that we'll be using. It's rated up to 100 microamps. It's the smallest meter I have. The rest of them are in milliamps or amps. This one is in microamps. So that's the meter movement that we'll be using, and the resistor that we'll be using is this honking thing, which is called a decade box, and you can switch in the various resistances. So this is our resistor, and this is our movement. So we're just going to use Ohm's law to figure out what this series resistance should be. We're going to put 10 volts in here, and we're going to deliver 100 microamps through the circuit. So we're going to want to have V equals IR, which means that R equals V divided by I, V equals 10, and I equals 0.0001 amps. So let's calculate R. R equals, and we're going to have to do 10 divided by 0.0001 equals 100,000 equals 100k ohms. All right. So now they asked us to consider the tolerances. So actually the resistor that we'll be using is plus or minus 1%. As you can see here, but they did say in the lab that we'll be using 5% resistors. Anyway, this 100k is not exact, is it? And the meter movement is about 2k. So with respect to 100k, 2k is not very much error at all. So these are about right. They're pretty close to each other. 5% of 100k, 100,000 times 0.05 equals, so that could be anywhere from let's say 995,000 to 105,000. And then with the contribution of the 2.2 K, it'll be larger than that and potentially larger than that as well. But the actual values don't matter much. It's all sort of roughly about right. So we've calculated that this value for the series resistance, to turn our movement into a voltmeter, we're going to add a 100 kilo ohm resistor. So this is the circuit. This is RS. We'll put RS there. So let's wire it up together. We're going to need to send positive power in. We'll put it in on the far side here. And then we're going to need to connect the meter. This is a series resistance, so we're going to connect it over here. We'd want to be sure we don't turn the power on until there's actually a resistance dialed into the resistor, or we'll deliver too much current. This is the negative power supply. And we're going to want to measure the voltage across the whole thing with our voltmeter, as well as indicating it on the dial here. And so the dial ought to agree with the voltmeter. Can you see that? I think you can. All right, so we're going to use the EV blog BM2257 in voltage mode. Put that there and that there. Okay, so now I'll just show you on the in the notes here how the can I put that up the back there? I want to make sure you can still see it. All right, now the meter will be testing with the how do I indicate a voltage meter? Maybe like that. So the voltmeter will be the EV blog meter, and we'll be measuring the voltage drop across the whole circuit. And we're going to pump in 5 volts. So let me just V set 5 enter. So let me see if I can show you that just quickly. There we go. Throw it over there. And this is the power system here. It's V set 5 enter. The overcurrent is set at 1 amp. We shouldn't be drawing that much. We should be drawing almost none. So yes, as you can see that the voltage is all set up. So let's pop back over here. Now I think we're ready to turn our circuit on. We've got the voltmeter in place. We've got our series resistors in place. We need to put on our 100K. So that's down here, 100K. We're going to make our resistor 100K. We're going to pump in 5 volts. We expect to see the meter deflect halfway to 5 volts, or it'll actually measure at 50 microamps, which will be analogous to 5 volts. So let's turn the power on, and bang, our meter's gone up to 5, which is what we're expecting to see. So when RS equals 100K, we've made a voltmeter out of our meter movement. Cool. We might as well go on and do the current meter. We'll get that done today as well, because this was a pretty quick prac. So let's do another one. The next job is to make an ammeter out of the movement. So I'm going to take a break, think about it, and then we'll continue with that. All right. Well, before we go on with the thing, let's just read what the book said. So it's a pretty brief section. It just says here 1L.4.2, 10 milliamp current ammeter. Show how to use the movement plus whatever else is needed to form a 10 milliamp full-scale ammeter. This is a bit trickier than the 10 voltmeter. Sketch it and test your circuit. So we're going to try and turn our 100 microamp ammeter into a 10 milliamp ammeter, and we'll be doing that by means of a shunt resistor. So we have to figure out what the shunt resistor needs to be. I might as well just label this separately, LAOE 1L.4.2. And this is going to be okay. I'll take a break. I'll be back. Okay, so I've been thinking about what we're going to do, and I'm actually going to leave it there. So we've done the voltmeter out of the meter movement. We figured that we could just add a 100K ohm resistor in series, and we'd get what we wanted. The mathematics for the ammeter is slightly more complicated. I want to go through it carefully. We might even do a couple of examples. But before we wrap up today, we'll do the ammeter next week. This week we're doing just the voltmeter, as I said. And let me tell you, I forgot that I made this circuit. This is the movement interface. And I put 2 diodes in parallel and inverted. And the idea was to take that and run it in there for doing our interfacing, because the diodes protect the meter movement from over voltage or situations. So I decided that this is a bit clunky. What I'm going to do is put those diodes straight in here. So I thought we might do that together now quickly in preparation for our next experiment, which we'll be doing in the next lab. I'm not sure if the next lab will come out. Just give me 1 second. Yes. Okay. So I just checked my calendar, and the plan is to pick up next year. So this video that you're looking at now will be the final Learning the Art of Electronics video for the year, and we'll pick up again next year. In the tail end of this year, we're going to be doing the Advent calendar project, so that there'll be more about that in the show. Channel News tomorrow will cover what we're doing in the tail end of this year. So the current the ammeter, we're going to do that as the first circuit next year. But what we'll do right now is we'll just sort these out so that the diodes are in place for protection, and we might do a couple of them. Let's just see what we've got here. Okay. So we've got 1 milliamp scale, 10 milliamp scale, and this is 100 microamp scale. So I'll do at least 2 of these, maybe 3 of them now with you in time lapse. All right, so that's the 100 microamp done. We've got the diodes in place, so we won't need to mess around with this little board. Now let's just see if I can find more of these, and if I can, we'll set up the 1 milliamp and 10 milliamp as well. So let me go digging. All right, well, this is my box full of extensions for banana plugs. Got one of those red. We're going to need one black. Is there a black? Let's get these out. What have we got in here? There we go. All right, so I've got one pair of red and black, and no more red and blacks. No more red and blacks. Yeah, let's see one. All right, so that depletes me of these kind of adapters. I'll order some more. And we've got enough for one, so we won't do 10 milliamps. And we will do 1 milliamp, so we'll do that now. All right, well, that's two done. I've got these done and these done. So we've got a 100 microamp and a 1 milliamp, and those will be available for us when we pick up this project again in the new year. So that concludes the video for today. I'll throw you over the farewell cam. We'll wrap up. And that is a wrap. I had planned to do some notes revision, but we can do that again next year when we pick up the project again. So today was just the voltmeter. We made the voltmeter by adding the series resistance. When we pick up the project next, we'll be doing the ammeter. That will be with a shunt resistance, which is a parallel resistance. That's a little bit more involved to calculate. So we'll run through the calculations for that when we pick it up in the new year. So this is the last video in this series for this year. There's going to be a week or two doing the Maker Advent calendar. So we'll be doing that as a bit of a break, of a bit of a change of pace over the holiday period. So that's the end of this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.